So tropical cyclones are very large scale circulations. So they large rotating storms. So they could be on the scale of 1,000 kilometers, really, really large systems that rotate and they rotate anti-clockwise, and that's why we call them cyclones. To start off tropical cyclones, there are sort of several conditions that we need. The ocean needs to be quite warm, so we have sort of a notional idea that needs to be about 26 degrees, which is quite common in the tropics. So that's a condition that's frequently met, but obviously not met at mid-latitude. So that's why we really talk about tropical cyclones here. The other condition is that we need some Earth rotational spin, which explains why tropical cyclones don't really exist right at the equator. They tend to form at least 5 degrees north and then up to wherever it's warm enough. So you need the rotation of the Earth to help create this large cyclonic motion. And there's also some other environmental conditions in the atmosphere. We talk about something called the wind shear, which basically means if there's a large difference between the surface level wind and the upper level winds, then cyclone finds it very hard to develop. So we call this a shear. So if the shear is very large, the top of the cyclone will be blown off very quickly, and we really need a cyclone to develop in quite benign conditions, which is low shear, so very little wind at all altitudes, ambient winds, if you like. Tropical cyclones is really the catch-all term that we use in research, but in certain basins, people use different words. So in the East Pacific and the Atlantic, people talk about hurricanes. In the Northwest Pacific, people talk about typhoons. Everywhere else in the world, people talk about tropical cyclones. So tropical cyclones is the umbrella term, I would say, and then typhoons and hurricanes are sort of regionally specific. But physically, they are identical. There's no physical difference between them. It's just a naming convention which is stuck from historical reasons, really. So the intensity of the a tropical cyclone, conventionally we measure by the what we call the maximum wind speed or sustained wind speed. So often we don't have a direct measurement of that over the ocean, for example, but we have indirect measurements from satellites, roughness of the sea, cloud structures. And then so we estimate the maximum wind speed, and these wind speeds are then sort of put into bins, if like categories. So there's the Saffir-Simpson scale, which is widely used in the for hurricanes. So that's this idea of a category 1 all the way to a category 5, where category 5 is the most damaging wind speed category. So tropical depression actually forms early on. So these are small changes in pressure. So that's what we might call it a depression. So if I think about a fully developed tropical cyclone, it might be 990. We call it hectopascals. The normal pressure in the atmosphere might be 1,006, and the depression might only be 1,005. So it's really just a weak system, which happens quite frequently. It has some circulation, but it's really just what we call a pressure deficit. So there's a small drop in the pressure, and it's sort of a nascent storm, really. That's what we would call a tropical depression.
Tenemos en el Mar Caribe la depresión tropical 18, un organismo En el país, lo que está ocurriendo, pues, durante las últimas horas, les decía que lluvias en zonas del centro del país, mientras que en el occidente, pues, también en horas de la noche será baja la probabilidad de lluvias.
The wind speed minimum threshold for what we call a hurricane strength or typhoon strength is 33 meters per second. So that's the benchmark we determine, and then we call it a hurricane, and then we that's what we call a category 1. So that's the lowest possible wind speed. The role of climate change in terms of how they affect the frequency and intensity of cyclones is complicated, but we split it into two, really. So we think about the intensity of the cyclone as driven by the ocean temperature. Why the ocean temperature? Because the ocean temperature drives moisture into the atmosphere, and the moisture is the real fuel for the hurricanes, the cyclones, and the typhoons. So as the moisture condenses, it creates heat, and that creates the whole circulation. So the moisture from the ocean is a really important part of the intensification. And under climate change, we expect warmer oceans, we expect more moisture in the atmosphere, we expect the storms to become much more intense. The question of frequency is a different one. It's a question of what are the dynamical conditions. So what are the wind conditions that allow the formation of cyclones in the first place? And for example, we talked about wind shear at the beginning. So what are the environmental conditions that favor low wind shear? We also need large-scale circulation patterns that favor maybe tropical depressions to be formed. And these are dynamical questions in which we're much less confident about under climate change. So we're quite confident the storms will become more intense, and we think that the frequency might decrease a little bit. But the worry is that the number of major hurricanes or strongest hurricanes will increase under climate change. The issue about intensification is that, yes, we can adapt and we should have more early warning systems, but our climate is also on a runaway path, right? So we also need to stabilize the climate. So reductions of greenhouse gas emissions is also part of the story. It is not just a question of adapting. We also need to reduce the greenhouse gas emissions because there's a limit to how much you can adapt to something that is extremely catastrophic. We can predict quite accurately when a cyclone will land and where. We're still struggling often to predict the exact intensity. So it could be that sometimes people are caught out when they think, oh, it's a storm they can manage quite easily, but then it suddenly turns out to be much stronger. But overall, yeah, with intensity increases, we expect much more damages, and coastal communities will be in the front line. To prepare for cyclones, we have this idea of an early warning system. So this isn't just a weather forecast. This is also then converting the weather forecast into an action. And the most common action communities undergo is evacuation. So you basically, if it's a severe hurricane or typhoon or tropical cyclone, you just have to leave. So that obviously means leaving property behind, leaving your lifetime investments behind potentially in your house and so forth. So property damage is almost inevitable, but we can certainly avoid loss of life by evacuating. In terms of property damage, of course, we can build better. So depending on the resources in the country and the resources of an individual, we definitely know how to build better. So, and we know that there's a very large difference in developing countries and developed countries in terms of how resilient the buildings are.